Okay, so we are live, and I will do a quick sound check first. Meanwhile, I can also just share the link of the slides. We should make sure that students in the same room can also see. Okay, it works. Good. And there are the slides. Soonish. Yes. Awesome. So this is from the last lecture, and we were talking about unit tests last lecture, and we were talking about different ways that code could be hard to test. And I gave you this slides with a lot of different kinds of code, and the solution for almost every type here was mocking. But I'm going to show it so that we can read it also. So the first one was we could have code that is unreachable or hard to, write code so that we can, enter a certain if statement. So for instance, we could have one if statement in one part of the code, making sure that we never go into another if statement. So for instance, we could have validation of input. So let's say that we in the user interface or the web applications front end, we check input and we give an error message if you're not giving correct input. So this is not a number, for instance, or something like that, right? And then since we have that check, that if statement already, we will never go into another if statement checking the same thing. So that could be unreachable code. And I've found in my code a number of different ways this can happen. So I can have complex code that is really does too much. It's so intertwined with other kind of code, so-called spaghetti code. So that makes it hard. We can also have static code. So we cannot really replace a difficult dependency. And we solved that also. With static code, we solved that by not having static code. So if you use the static keyword, or if you're placing things, too many things in the global namespace, you should change. I mean, this is a strong hint from me to stop doing that. This is not a good solution, whatever other people might say, right? I know better. Error handling. Oh, it's quite common that I mean, we do error handling, but this error can never happen for some reason. Or sometimes if this happens, the entire building is also burning. So it doesn't matter really if this error happens. So and then in some cases in Java, for instance, we need error handling just because Java wants error handling. So you need to check for a specific exception, but that exception can never happen due to other code run before it. And then object creation. So we need to, if we're using the new operator to create instances of classes, so-called objects, then that new of that class is hard to replace. So we get a difficult dependency. And that could be solved by factory pattern and then mocking the factory. Also, if we have a difficult dependency, like to a database and stuff like that, that dependency makes it hard to test. So imagine that you have a function or a method that writes to the database and it never returns anything. So with normal asserts, we cannot test this. So, or we cannot test this easily as if a method returns something. So we could, like, if the write to the database succeeds, we return true, and we can test that we return true, right, with a normal assert. But if you're going to check that we actually wrote the correct thing to the database, you need to do a bit of magic, right? To unlock the database, you can, from your test, look into the database and check there. and make sure. But that is messy, and that is also slow because it becomes 2 database queries. So you write to the database and then you check the database, and that is a slow test. And I gave you the story of slow tests also, that with the German car manufacturer that had 2 weeks of runtime off the test, no manual intervention, just runtime, right? So that gives a turnaround time, which means that the time it takes for producing one type of code, realizing that it's wrong, and then changing that and try it again, right? So that was longer than 2 weeks. I mean, the testing runtime is just one part of that time. So we want tests to be super fast. I told you last lecture. And the way we can do this is that we create some kind of mechanism to replace the database during tests. And we're going to do that with mock objects. And then we could have difficult state that makes it hard. So usually we try to mock that also. So everything that is sort of static or global namespace and stuff like that, that cannot easily be replaced, we try to avoid such things to make our code more testable. And that also makes the code more flexible, because then you suddenly can replace these things in other cases also. So your code is not as tightly bound together. You have mechanisms for interchanging pieces of the code, which is good for your code. And no return values means that, then you need to test another way, which is test the behavior. And we're going to look into that also a little bit. If we have indeterministic code, so imagine, or I gave you the example from my test cases, which was time dependent. So on Sundays, a bug occurred, but no other days of the week, just Sundays. Which means that in order to find that bug, we need to test it on Sundays. And I wouldn't say normal people, but if the work week is usually Monday to Friday, right? And then we have students that are working Sundays also, right? Because they need to. Yes, but almost everything is solved by mocking. So today we're going to look into mocking a little bit. And yes. So the first thing we need to realize in order to mock something is that we need to dependency inject. And I want to, show you some code. And then we're going to talk about dependency injection. So actually, I'm not going to show you the code. I'm just going to show you the sort of interface of the code. So this class is called an article. It has a constructor, which takes a string, the text of the article. So this is a news article, right? So the content. And I just save that. And then I have 2 functions. And I believe there are errors in it because I wrote it and I didn't test it. So there should be errors in this. The first one is called getWordCount, and that is a public method. And then I have a private isWhitespace that is used by the getWordCount. So essentially, the getWordCount means that I'm going to count the number of words in a string or in the article. So if it's hello, my name is Daniel, then we have 5 words. We don't count the dot, we don't count white spaces and stuff like that. So that is the idea of the getWordCount. And then we have another article that is dependent. No, we have another class that is dependent on the article, and it's called a newspaper. And the newspaper is a collection of articles, and I did that with an array list. So an array list of articles, and you see that I've opened up an add method so that you can see the fantastic internals of that. So we can add articles. So from the beginning, the newspaper is empty, and then we add articles, and then we can get the total word count for every article in the, and that also contains bugs. So, but very simple code. It's not that I don't know how to solve these problems. It's just an example, right? And we would like to test this. But the first is that we have a relationship between these two classes. The newspaper is dependent on article, and we can see that because we use the article here. So the name is here, and so this means a dependency. So every time you write the name of a class within another class, you are dependent on that class. So in this case, it's an argument. But since we changed the internal state of this newspaper, all methods are presumed dependent. Right. Okay, so we're not going to look into that one, but we're going to start testing these. But this thing that I did here is dependency injection. And just so that you know how to differentiate if we don't have dependency injection from having it. So I'm going to do this. I'm going to write string. Then I'm going to say article content. And then new article content. So I'm changing the interface a little bit, and now I don't have dependency injection. So the dependency or the creation of the articles is inside the newspaper. So let's keep it this way, and then we start testing and things like that. Okay, so I've created also an article test and a newspaper test. So I'm going to start with the class that has least dependencies, which is the article test. So let's create a test for that. Test should return should return 0 for empty. And I need the return type because I'm not used to Java, but it's void. Then the first thing that we need, or the different parts of a test case, was input. And I need to write string. And it's an empty string. And then we need a system under test in order to test something. I always call it SUT. And now we got that one. And then I say the expectation, which is 1 word. No, 0 words. Hard to count. And then we exercise the system under test. Notice the word exercise, which means that I'm trying out. And in order to be accurate, for the accuracy part of the testing, that we want to test as little code as possible. So I'm not creating a newspaper now. I'm creating an article, right? So, but we want to find out the actual output, and then we call the method on the system under test. So let's call it the get word count. And now we compare these two. And I think assert equals is pretty good. So expected, actual. And yeah, it should be called expected, like that. And now I go to the testing, and then I can close that thing, because I'm not interested in those parts, and I only run the tests that are interesting. And it succeeded. Great, our article works, but it doesn't, because we only tried one thing, right? And do we really know anything about the implementation of article? Not really. The only thing that we know is that it didn't crash, didn't throw an exception, and it returned the correct value, but for one empty input. So and I always do this, and this also comes with some problems when you do that. You copy paste stuff, but it's quite nice. Should return 1 for one word article. And let's have one word article and one word article. This is, I want you to react on that. Remember what to do last lecture, what I said, that how to work with your input so that becomes easier. Simple input, thank you. So I will needlessly long, good, Albert. So we reduce that to the simplest input, which is an O perhaps, just because I had only. I don't know, doesn't matter. We changed the expected. It's quite common for me to not change the expected when I copy paste stuff. We notice that we have duplication of code here. You did see me during the lecture tests or the math test, I think it was, having my own assert method in order to, make this a bit. But let's not worry about that thing right now. So let's run this test also. And it works. Oh my God, this implementation is so great. So let's try it again. And let's have a 2-word article. 1, 2. Here we could, we could abstract this to a, multiple word article. Should return count for a multiple word article. And maybe, we make it a bit more complex, like 1, 2, 3, or something like that. But I like to keep things simple and small, especially when I'm debugging, so I'm going to keep it like that. Nothing else needs to change. I run that, and it fails. Oh my God, we have a problem here. I'm not going to fix the problem now. I just want you to notice that article tests fails. And then I want to have, didn't I have a newspaper test also? Yes, I do. So let's move over to the newspaper. Now we know that article is almost correct. It has 2/3 of the test cases passes, right? The newspaper test, so let's create test cases for those also. Test void should return 0 for no articles. And since I'm lazy, I'm gonna, copy something from this one just to get everything faster. So I'm not creating new articles anymore. I'm creating newspaper. And a newspaper doesn't have any input, at least if you don't have any articles. We expect an empty newspaper to return 0. And let's run that. And it succeeds. So we didn't find any bug, but it's still valuable. We know that it works for at least some input, right? It cannot be all wrong. And then we introduce another test case. 1 for one article with 1 word. Sure. We create the system under test, and let's add some stuff to this, and then we create an article of 1 word. Oh. Usually, if I'm doing this and I know that I've already tested with O, I would probably just take the opportunity, because I'm just randomly selecting a letter here. I would have A here, just so that, even if these are testing different classes, I would have different words. We would expect that to be 1, and then we run that test, and we come up with that. That also succeeds. What is wrong here? It seems to be not much. Okay, let's have 2 words in that. or let's have 2 articles. Oh, yes, 2 articles. So one is called A and one is called B, and then the total count of words with 2 articles with 1 word in each should be 2. And that didn't work because I didn't change name, which I consider a feature. We run, which is called the regression test, and we found something. So if I had 2 articles with 1 word, it doesn't work. Actually, this is sort of problematic. We can deduce from this that, okay, we have 2 different bugs, one in article and one in this one. However, if I have this A, and B, and I change to this other test case, and I rerun that, it should also fail. Yes, but this fails perhaps due to other reasons than the first test failed. So yeah, it must. Yeah, we need to change that also. Very thanks for the catch. I'm always forgetting about the expected. But this, okay. So we see that expected was 4, but the actual was 1, right? So, but the interesting thing here is that this input was the same input we had in the test of the newspaper, right? So it will cause, I presume, the same bug, right? So we will get the wrong output from the article, which means that this test will also fail, but for different reasons than if I have. So I'm gonna on and 2. So now I have two failing test cases. I should have those. Yeah, 2 failing test cases, but for 2 different reasons. One for the bug in article and one for the bug in the newspaper. So this is creating a situation where we don't know where to look for the error. If we're looking, we don't know where, we cannot really accurately decide because we have test cases that are dependent not only on newspaper, but also dependent on article. So I'm just gonna, because I forgot to put it up, I'm just gonna find an image for that. And which was fun. Not access it. So this talks about other classes, but what the heck. So we have 2 classes, order and order row. And we would like this state. So this is the article, the order row is the article, and the order is the newspaper, so to speak. And we would like, yeah, this is the wrong image. That is why it's, let's see if I can find the other ones. New. Let's use that anyway. So yeah, I'm gonna change it also to make it even newspaper. Why? We have article. We have a bug in newspaper and a bug in article, and both tests fail. And let's use this red. Oh no. This red? Yes. So now I have the image that I wanted to show you, more or less. So we have a bug in newspaper and a bug in article and two fails, so to speak. And this is problematic because we don't get accurately guided into the class with the error. So we need to debug more code. And I mean, this is simple, but in cases I have seen, there are long dependency chains. So one class is dependent on another class, which is dependent on several other classes, which are dependent on several other classes. So if you have those long dependency chains, this is now no longer simple. It's quite hard to debug things. And for some bugs, you cannot even debug. But that is another thing, right? So what we would like to do is that we would like to newspaper test. We want that to fail due to only to bugs in newspaper, and the article test should only fail if it's a bug in article. Let's try to approach that in the code by removing during the test the dependency to article from newspaper. So the article test is going to be kept just as it is because it's fine. It's detecting the bug and everything. But the newspaper test we need to look into so that they are no longer dependent on articles. So one problem is now that I cannot replace article because inside newspaper, we create instances of articles. We're just sending it a string. So the first step would be to start sending it articles instead. Have in the beginning, right? So article. And I'm just going to remove these test cases. But we only have one. And that one. Yeah, that is okay. So here, it would be cool if I could replace this one with something else. So we could create, a class called article stub. And this class could extend article. And quick fix, I need one of those. I also need public int get word count. Return. And the cool thing is that if I do this, I can send this an article stub instead of an article. And the article stub, I can control the implementation of that. So it just returns a 1. So right now, this doesn't work. So we're going to fix that problem also. Let's go to the code. The newspaper, it should not. To be added. Now the newspaper takes articles. Now I can look at the test and I can see if this. Okay, I don't know that. Oh, this one took an, yeah, just need that one and just have something here. That makes it a bit simpler. Okay, so let's see if we can make this work now. So we have a newspaper, we have an article stub. It always returns 1. So if I have 1, it should succeed. So I run this test. And that succeeds. And I can even do this. I can have change this number to whatever number. So we define a correct answer from the article stub. It's ours to decide, right? So we don't have any code that computes anything inside the article stub. We control it. So this is the part of the testability that we say is controllability. if I stub a class and replace the difficult dependency, the code that potentially contains an error, with something that cannot contain an error because we define it, then I'm more fine. So let's create another test case using this one. We had the one we tried to replace the one that we had problem with return total count for 2 articles with 2 words. Right? So I do this one and now add 2 article stubs, which means that total get word count becomes 4. And the interesting thing with this test is that it's not dependent on the implementation of article. So it fails for the right reason. It's independent of the failure of article itself. So you noticed a couple of things that I introduced this article stub, and this is something that, I mean, you can do this. It's a feasible thing, and sometimes these stubs can need to be more complicated than this because you need to, you know, perhaps first time the word count is, or get word count is called, it should return 1. The second time it should return 3 or something like that. So it's suddenly it becomes like this, Boolean first call equals true. Oh, it's not. Then if first call return 1, else, and then we have first call equals false, return 2, and stuff like that. That can be done. I mean, you can see yourself writing that code, but this is a lot of code. And this we can, you know, make more effortlessly using mock objects or mocking libraries. So mocking library does this for us. So we can configure a stub using a mock library. So I'm going to show you a mock library called Mockito. So it's site.mockito.org. And the Mockito library allows us to build these stubs. And we can configure these stubs. And we can say what is going to happen if we do stuff on it. So let's look at this code example here. So it's just their example. And actually, these examples are, I've seen students misunderstanding these examples quite thoroughly. So I'm going to try to guide you through it. So we have a difficult dependency to a linked list. So a linked list is a data structure that is a list. So you can create a mock object of that. Instead of me creating an actual class like I did with my stub, I just write mock, and then I write the class, the name of the class. And now I have a linked list here, but none of the methods are really doing anything. So the mock object sort of looks like empty methods when we create those. I think they actually like return 0 or something like that, just to work. And then I can configure it and say that when someone calls get on the list, get with 0 as an argument, then we should return first. So this is sort of, I'm just going to call it get. So sort of this code automatically gets generated. I get a class that looks like this, more or less. So that is quite useful because then we can, you know, configure our mock objects, and then we can run tests and find ways into the code without being dependent on other classes. So we can remove difficult dependencies. So if you have a database, you can mock the database class, and instead of actually calling things to the database, you can just return things. So if you have a database class that returns a big dataset, JSON dataset stored in some database, you can just return a controllable dataset that you have control for in your test, which is really useful, both for this independent testing, because you sort of remove this dependency during test. And instead, you're dependent on the mock object. Okay. So that was dependency injection. And there are fakes, stubs, and mocks, and you can read about those here. Yeah. So the Mockito had a feature where we can replace difficult dependencies with configurable mock objects. We get better accuracy, I don't know. And we also get, able to create these cool stubs that allows us to do funky stuff. I'm going to show the other cool stuff that you can do with mocking, which is to test behavior also. And this solves some of the hard to test problems that we showed before. So let's look at those again. This one in particular, no return value. So some methods doesn't return anything. So how should we test those? And previously, you perhaps, if some method was writing to system out, you could replace system out with some other kind of stream, and then you sort of catch that anyway. Or if some test is writing, or the code is writing to a database, you can look into the database and then find out, did it write the correct thing into the database? But now we're going to learn how to do that without this messy way, using Mockito instead. So the cool stuff in here is that, let's look at the code in here. So we have a mock object, and some method is called on the mock objects, and we have configured it to return true when that method is returned. So this is the configuration thing, or the controllability thing. And then we run this, and now we check the behavior. And it's in Mockito, it's called verify. So we verify that a specific method is never called. But we can also verify that a method is called. So if, let's say, we communicate with a database class, and it has a query method in which you send it a SQL query, you can configure it that when the query method is called, then you should return this thing. But you can also verify that the query method was called, and you can verify that it was called with specific parameters. But I think that we should take a break, and let's have like 5 minutes past 2. I think that is enough. Okay, so welcome back. And we were talking about mocks. And I said that mocks could be used to increase controllability. So we get configurable stubs that we can, they can act as the difficult dependencies, or any dependency really. But it could also test behavior. And I was talking about verification, or it's not called verification because that is a bad word to use, since we have a specific meaning of verification in this. But it's in Mockito, it's called verify. It could be called other things in other mocking libraries, right? But if we look at this example, we have a view mock, and we mock some class that we are dependent on. We dependency inject that mock object into the one that we are testing. So the roll dice game has a view mock dependency injected into it. There is something called spy. Also, I'm going to briefly mention it later. And when we run our test, we configure the mock object to work in a specific way, and then we exercise the system under test, and afterwards we verify that methods are called or not called. And yes, and the Mockito framework has different ways of doing this. So if we look at this example here, we can see that we can verify that 2 different methods were called, and we can verify this is actually an argument to the method, which means that you can make sure that a specific method was called with a specific argument. So for instance, if you're talking to with databases, you can make sure that the correct database query is called using, your yes. There is other things. I'm not sure how I found it. It was training. I think it was links. The documentation. Links. Wasn't it training? How more? I think more it was probably. Main reference document. And if we take a look at the different examples here, we can see that when we configure an object like this one, when was used to configure a mock object, and then the method that was called, the argument it was called with, and then we can do different stuff. So for instance, we can have return values, or we can throw exceptions. So in this case, we mock a linked list first time, or when it's called with get with a 0, it's going to return something. If it's called with a get with a 1, it's going to have an exception called. We can also do, really complex stuff like down here we have a mock list contains is called on that one, and we can we can do really complex stuff in how we configure these objects. And we can also do complex stuff when we verify stuff. So I'm going to see if I find the example. Yes, this one. I think it's quite interesting. So here we want to make sure that a method is first called with an add method is first called with one argument, and then is called with a second argument. And these must be called in this order, and we can configure that. So this is not a course in Mockito, and that is why I'm just giving some examples here. So when you are, need to learn this, you look into the mocking library. And in assignment 1, part 2, it's going to be examined that because in that assignment you can choose the language and the library or the frameworks that you're going to use, but you should be an expert in the framework that you are using. And if you're using some other kind of mocking library, maybe this doesn't exist, right? But you should be an expert in your library or framework. Okay, so I think that is enough talking about mocking, just because we have other slides to reach, right? So When we have a suite of tests, we want to make sure that we have a good suite of tests. And we could, do stuff like, we could think about what are good test cases, the test selection problem, right? We try to make sure that we try different things, and we try different things because we know the code works in different ways. Or we try, 0 and we try 1, or we try, if we have a control statement, we make sure that we go into the control statement, or we go out of the, or not into the control statement. But there are ways of doing this automatically. And one way is called coverage. Another way is called mutation testing. A third way is called checked coverage. Coverage is covered in another slide, but that sort of means we measure how much code of the system code that is run when we run the tests. And code that's run when we run the tests, we call that covered code. And if we have 100% code coverage, then we say that every line of code in our system was run during tests, so that means that our tests are good. But good could mean bad, because just because code is run during tests doesn't mean that it's actually working. Because you can have a test case that succeeds, and you've seen this today, right? Even if there are bugs. So we could have a test suite, we could have several test cases running, but it has the wrong input that doesn't cause a failure. And then we can have mutation testing. Let's say CS Quiz here, and CS Quiz was the replaced first assignment. But what mutation testing is that we have a test suite, and then we have the system code. And we say that, what if we introduce bugs into the system code? And then we say that the test suite is a good test suite if it finds the bugs, if it can differentiate between the system code and the buggy system code. And then finally, we have checked coverage. And I think there is a separate part of a separate lecture on this. I'm not going to go into that much, but this means that what is asserted, does it rely on calculations done on the code in the system? And we only call lines of code checked covered, if they also contributed to the decision that the assert made. So, for instance, you can have code that computes something, right? And then we have an assert that checks that the computation is correct, right? But you can have code that computes something, and then you have other code that does other things, like it does a system out print line. It doesn't contribute to the assert, success or not, right? So if it doesn't contribute, that code is not covered with checked coverage. Code coverage can look like this a few years ago and in Eclipse. So we can see different lines of code, and we can see that the green line here is covered. The if statement is not fully covered because we only go into it. We do not go, the else part of it. And then this Boolean is not covered. There is no test running on that one. And so we can get, overview of the code in this way. Some coverage tools does that. Some calculates numbers, so we can say the Sudoku board is 50% covered, but the no argument exception was 100% covered, right? But this does only mean that these lines of code are run during a code. We don't even need an assert statement. So I have seen examples of not students, maybe students, but I've seen tests where the developer was so annoyed with the failing test that they removed the assert, which means that you suddenly get a succeeding test, but you actually just hide the error, right? So we can have 100% coverage of any kind, more or less, and yeah, not not every kind, but still not functional code. As you see here, there are different kinds of coverage. We're not going to go into those today. Then I have a couple of questions, and I want to look into this. I'm a little unclear about what you did with testing no return methods, because it seemed like you had the luxury of white boxing. If you black box it, do you essentially try to figure out from the documentation what should happen? Also, so suppose you have a method like in some, yes. Okay, so I essentially get two questions. The first one was, if I don't have any return statement, then I can verify that certain methods, what's called on the inside of the class. If I only calculate stuff on the inside and I don't call any methods, then I must examine the internal state of the object, which can be messy. And then I get another, so if you, so I get another question regarding the internal state. So if we have an internal state of the object, this can be messy because maybe we want to hide it on the inside and only have it private. So we might do something. I think Spice can do this, but I'm not sure. But an internal state that is private usually means that your class does too many things, and you might want to, perhaps expose this variable or not test it. So usually I advise students to only test the public methods. There are testing frameworks that can expose what happens on the inside of private methods also, so that you can create a test case for a private method. But usually I would advise to split this class into two different classes, so you have sort of an outer class and an inner class, and then you can test the inner class because the previously private methods are now public, and you can test those. So I want you to explore this in assignment 1, part 2. So you try to do this, and then you come up with ways of doing it. So I think that is much better than me telling you what to do, because I've experienced it and then I've learned stuff. But I really want you to experience this. When should we start on assignment 1, part 2? As assignment 1, part 1 deadline hasn't been set. So I would say that when you're done with assignment 1, part 1, you start with assignment 1, part 2. The deadline is, I'm going to set it, probably you're going to have 1 week for assignment 1 now. I just need to make sure that you get some supervision, or not supervision, tutoring, which I still haven't done. Yes, we were talking about quality of tests, and that some test frameworks could give this to you, and some external tools can also give this, and there are different types of that. Now I want to go into the last part of this lecture and make sure that we get this part, because this is relevant for assignment 1, part 2. In assignment 1, part 2, you can work in pairs. And you're going to do something called test-driven development. It's really good if you have this book. I know that many students found this PDF somehow. So you can read that book. It's an easy-to-read book. And test-driven development, or TDD, is very specific in this book. And we're sort of following that specific version of TDD. There are a lot of people talking about TDD, but they are actually talking about something called test first, or meaning we have unit tests. But TDD is something specific, and we're going to talk about that. But before we do that, I want to go into why TDD and Agile sort of came. And this is it's history now, but anyway. So before Agile testing, and in my times, many companies still do this. And I know because I've done interviews with testers. So we have a set of requirements. And students also learn this way. So we have a set of requirements, and those requirements lead to system testing. And system testing, was that we have the entire product. We have, the back end and the front end and the database and everything put together. And you also remember that we had beta testing and acceptance testing, which was usually system testing. So requirements lead to system testing. We test the entire product. But since this was system testing, we needed the entire system, so we tested after implementation. And perhaps we also need to wait with testing until the front end guys or girls have completed their task, right? And we need to wait for the database girls to finish their things, right? Sometimes in the teams, they had different teams with testers or different roles with testers and developers, or programmers and testers. Now these roles have gone together, merged together, because this is quite bad. And I did an interview where the interviewee told me about the conflict between the testers and the programmers. I think I told you about this before. This is causing long turnaround time. And last lecture I told about we need fast turnaround. We want to make sure that if we have a bug, it should be fixed, and then we release, not a long process, right? I was talking about seconds, and I was talking about like few seconds. I don't want it to be 30 seconds. I want it to be less than 10, right? This also means that if you're doing system testing, you're testing the entire thing. This means painful regression testing. And regression testing was when we tested the same thing again. And if you're starting up a system and you're logging in or perhaps you're creating a user, then you're logging in and then you're buying 2 products, and then you're doing this over and over again, it becomes painful because you've done all these things. And when you're doing repetitive stuff, we call that checking. And I told you that as fast as possible, automate things, because checking we don't like as humans. We want to be, creative. We want to think. We don't want to follow scripts. And anyone who has had a job where you follow script, except me, probably didn't enjoy it. I can enjoy boring stuff. So even before they knew that they should automate fixes. So some were automated, but perhaps more manual. So the new way of doing this, the agile way, is that requirements still leads to testing, but not system testing, just system testing. We test during implementation, and while we're working, while we think about requirements, we start testing directly. Programmers and testers are in a team or even the same role. So we are developers. We're not testers. We're not programmers. We're developers. We want to have short turnaround time, seconds, quick regression testing, focus on automated tests. So this is what we want. So TDD fits very well into this picture. And TDD was coming up as a reaction on the non-agile testing. And TDD is a test last process. And okay, what does test first process, I mean. When we have a system or we write code first, and then we test the code, then it's called test last. So test first means that we write the test and then we write the code for the system. It is a low-level software development process, which means that it's not considered, it's not a rational process or rational unified process or Scrum or something like that. But this is a low-level process, which I defined it as low level, which means that this is what a programmer does, and it's like perhaps 30 seconds long, and you do all the steps in 30 seconds. So this is not something that you do, for hours and hours, or one iteration of this is just a couple of seconds. It's as much design as it is testing. So you're not only thinking about, testing, you're actually thinking about how am I going to write this code? How should it work? What should the interface look like? What should be sent here? And what kind of arguments should I have here? And stuff like that. Okay. So for many years, this was sort of falling out of favor because it's quite messy. It's hard to learn. It's a bit, when you're used to programming the way that you have been programming, you're going to think that this is slow and tedious, because it is slow and tedious. One part of the slow and tedious means that you don't know it good enough yet, and you don't have the tools and the skills for this. But the other part of slow is that, okay, you need to work in this particular specific way, and people don't like that. They like to be free and fly. So the way I experienced this, I hated this first, and you're going to hate it too. But the reason that we're going to do it is because it's good for you. So the things that are really good, that you really learn your unit testing framework, because you need to be faster in this, and you realize this is going too slow. I want to do stuff. So you need to be good at this. So you need to learn the unit testing framework. You need to learn how to write minimalistic, high coverage test suites. And this is really good, because if you're writing test last, you're not going to learn this. Because when you're writing test last, this shit is going to happen to you, because you don't think about testing. Your testability for your code that you write first is too low. The cool stuff is that even if it's painful to write test first, you'll actually learn a lot about testability, which means that you're getting better at writing test last then also. So if you think that after this course and after assignment 1 part 2, you'd never want to touch it again because you hate it. And I did think that. But then I did it again and became even better at it. Then you can still benefit from this, right? And you write testable code. So there has been a lot of research on TDD. This is actually a quite old study. There are many different studies. Some say that it took 15 to 35% longer to write code, and you're going to experience this. It's probably going to take like 200% longer, 500-600% longer, I presume, the first test you write, because you don't know how to do it. It's normal. You should learn. So the bug density of projects developed using TDD decreased by 40 to 90%. There are a lot of studies on this. They give different outcomes. So some studies says that it's even worse to write TDD code than normal, even for testing, right? And they compare it with peer review. So where programmers review each other's code, which seems to be the most efficient thing. So this assignment 1 part 2, you can do that in pairs. And I want you to do that in pairs, because then you get the peer review part also, which is really great. Okay, so this is how you do it then. You quickly add a test. And then you run all tests, including the new one, and make sure that the new one fails. It should always fail. And the first reason for it to fail is because you don't have any system code yet. You have not even written that. So compilation error is actually a fail. And then you make a little change into your system code. And then you run all your tests and see them all succeed. And this little change is actually cheating. So I want you to write the stupidest, easiest way to pass the test, not to solve the problem, to pass the test. So imagine the first test of a max method. We've talked about the max method before, that took an array of integers and returned the max of those. So let's imagine the first test that we write is an empty array, because it's the simplest test, right? And the max method, what should it do with an empty array? Throw an exception. We don't have a max for an empty array. It's undefined, right? So we make a little change to the system code. We create the method, and then we throw an exception as the only code. We don't calculate max. We don't do anything else. We run the test, make sure that it succeeds, which means that we made a change. And then we refactor our code to remove duplication. And then we do the same thing again. We add a new test case. Okay, how can we make this code fail? So let's add a max of 1 number. And then we change the code. we go into make a little change again, right? So we run the new test, and that fails because it's going to throw an exception. I want you to imagine this code now, right? So the system code always throws an exception, so the second test fails. The first succeeds still, second fails. So let's introduce a little change, which perhaps is an if statement. If the array is empty, then throw exception, else return 0. Or something like that. Run all tests, see them all succeed, and then you continue remove refactoring and stuff like that. So this is so I'm actually giving 2 examples here, and this is a previous version of JUnit where they expected exceptions. This is a Sudoku board test, and I test that if I call the Sudoku board with a null, it should throw illegal argument exception. I just did it in 2 ways, just to not follow this, because add one test, right? But these are essentially the same test. But what I wanted to show you is that if you have a test framework or you want to test exceptions, you can write a test using try and catch. And then if we reach this line here, the test should fail, right? Because it should throw an exception. And then we run all tests and see if the new one fail. Actually, both failed because I'm writing more code. And then I make a little change. If board positions equals null, throw new illegal argument exception, and then they succeed. And then I refactor. I remove one of the test cases because I have a duplication. I also remove the if statement because it was unnecessary to succeed the test. And then I regress, so I test the tests again to make sure that they succeed again. So I didn't change anything during my refactoring. And then we do this over and over and over again. So yes, so this is how to work in assignment 1, part 2. You're gonna work in red, green refactor, and then you're gonna do a commit on each step. So you add tests, you do a commit in Git, and then you change the implementation. Yeah, you add a test, you run the test, make sure that it fails, right? Then you make a change of your system code and make sure that the all tests succeed, and then you make a commit. And then you do your refactoring, and then if you did any refactoring, sometimes you don't need to, then you run the tests, make sure that they are green again, and then, or succeeding, and then you do a commit. And once in a while, you should also do a coverage measurement, and then you do a commit also with the measurement values. So this is in order for you to save what you're doing when you're doing it. So we have a commit history, exactly how you worked. So this also will show that you actually worked in a TDD manner, which shows that you've actually learned a TDD and not did anything else. So I'm writing not super strict, but strive to be strict. So when you're doing this, you're going to run into a number of problems, just as you're probably running into problems with assignment 1, part 1, which is fine. We want to reach these problems. We want to ask the questions. We should discuss some of the problems in the Slack channel so that we can learn as a group from this. I'm saying it's not super strict, which means that I want you to do this most often. And sometimes you run into these issues that, oh, I need to go back here, or I forgot to do a commit here and there, right? But you should not forget every commit. It's fine to forget some of these. Students previously did some, batch scripts so that they don't need to write commits. So they run the test and do a commit as one action. Not super strict also means that it's fine to make mistakes. It's fine to lose track of the TDD process and realize, oh, we forgot to do this TDD. Oh, but perhaps you step back then and restart from the point where you stop doing TDD, or you just say that, oh, this commit is not following the process, but the next commit is going to follow the process. So in the end, students are around a couple of hundred commits, because this is very small steps, right? And you should strive to learn different things here, not to reach an end product. So you're programming for learning, not to do anything, not to solve anyone's problem. So you select the problem. I selected the Sudoku problem once. I selected a physics problem once. I did a web server once. But all of these were really good practices. But the thing is that we want changes in your brain, not really solve any problem. So you actually don't need to succeed with your problem, but you should still try to work towards a problem. Students that got the highest grade had a couple of hundred commits, which means a couple of hundred or perhaps 100 cycles of this process. So we're going to try to help you during this also. Part 2 shouldn't be too big, to my understanding. Like, we won't need to finish it and just showcase our TDD understanding. Yes, so we're going to talk about TDD, and we're going to talk about your commits, and we're going to discuss a lot of the different questions, because in the assignment you can see that there are a lot of questions, and if you did this correctly, so to speak, then you can answer all the questions. But we also look at the number of commits and stuff like that in order to see that you've actually done this enough times. And we look at the JUnit understanding. Oh, it doesn't need to be JUnit. It could be the test framework that you're using and the mocking framework that you're using. And you should know these things. You should know all the methods in JUnit, sort of, to get the highest grade, right? As we're talking about TDD, should we involve no CI? So you don't need to do this in this assignment. No. Yes, I think it's a good idea if you like that, but let's not make this more complicated, because it's already really complicated, right? Okay, so there are a number of books that I think is really good. They are quite old, all of them. So we have the Clean Code book, which should help you to write clean code, and clean code have a higher testability. It's easier to test this one. So I know some of you have already had this in a previous course. The rest of you, read this book. It's going to make you a better programmer. And then we have test-driven development by example, which is the course literature for assignment 1, part 2. And this is actually voluntarily assignment 1, part 2, if you want a higher grade. And then we have a book called XUnit Test Patterns. This is a fat book, but I think that most of these can be found online. I think there is a website with these test patterns. So this is a book that talks about different problems of testing and different problems when you write your unit tests, and how to minimize those and how to become more dry. So you notice me copy-pasting a lot. I actually never get down to solving these problems, but there are ways of solving these problems. Yes. Do we have several chances to submit assignment 1, part 2 if you fail, or only one chance as it's optional? Yeah. So as it has been, as if you have done assignment 1, part 1, you sort of secured an E. So with assignment 1, part 2, you can only increase that E to a higher grade. And we only do that once. So I've never had a student that did not increase their assignment 1 grade with this. So no student is the worst student, but the student that got the lowest grade ever did get a D on assignment 1, part 2. Yes. But that was, maybe did a number of cycles of TDD, but perhaps 10 cycles, and didn't learn enough, so to speak, to get a higher grade. But this, I would recommend it, but yes, it's optional. Okay, cool. I think this is it. Thank you very much. Thanks for listening. And yes.